Hello, hello, hello. Ready to do quest 5 of Everybody Codes. A little bit more prepared this day. Got my quest template set up. These are backticks now, so when I paste, it's going to be a lot easier. You know what? I'm just going to make this even easier on myself. Dot trim. Love it. Clear that out. Clear the rest of these out, don't need them. A minute to go. Very exciting. I don't think I did any. Nope, made no. Didn't have time to go any optimizations yesterday. I will get to them eventually. 30 seconds. Here goes Everybody Codes Day Quest 5 rather. Let's do this. My notes. Got them. It's a bit much. The trim will handle it. It's my expected. What is the number shown at the end of the 10th round? Okay, I can already see that my thing is going to be going further rounds in this. Oh, excuse me. Okay. First clapper is person marked with 2 on the top left side. Okay. So, what? Things are going in between things. What in tarnation? Okay, I gotta read this. Pseudo-random clap dance. Receives a number from the master of ceremonies. We'll choose to place in one of 4 columns. Clapper is the first person in the first column. The first person in the second column. First in the third. Okay, so it's 2, 3, 4, 5, right? 3, 3, 4, 5. What? Tarnation. It moves to the beginning of the column to their right, facing its members. If clappers from the 4th, they move to the start of the first column. What in tarnation? Okay, day 5 difficulty curve. We hit it. Okay, beginning of the column to the right. So this one moves to the top of this column. And they get reabsorbed by their index. Got it. Okay, I'm starting to see. What in tarnation? Okay. Dances around the column from the left, high-fiving each extended hand. Upon reaching the end, they switch to the right and continue opposite direction. So they do this, and then 2 would continue walking, and then they'd walk up this path. I understand, kinda. The crowd counts each clap aloud, starting from 1. When the shouted number matches, the chest number absorption occurs. Okay, so 1, 2, and they get absorbed in front of the 2. Okay. Then they combine their numbers and shout. Okay. Second round goes like this. Second column, 3. You walk up to column 4. You don't do anything. You just walk 1, 2, 3. So you go above the 2. I got it. 3, 2, 4, 5. Okay. 4. You... Oh, yeah, this one. This 4 goes into this round. 1, 2, 3, 4. So what do you do at the end? You insert. Okay. 5. Go to the next column. 1, 2, 3. So you technically hit the last one 2 times. 4, 5. And then you enter behind. Okay, this is gonna be a fun off by one. I get to challenge. Okay, so let's do this. Jeez. Const lines equals notes dot split new line. Technically, the columns we care about. So const. Let's look at my input just so I might as well have it because I'm not doing this in no 2 minutes. Yep. Notes. Oh, okay. It's. Oh well, I guess the first one is easy. Sure. Columns equal notes length. Well, notes. Okay, it's 2 lines. Lines equals notes dot split the new line. Notes 0 dot length minus. Well. Okay, we'll just make a thing of columns. Figure that out later. For let. I guess we can just do regex matching. That'll work. Hold on. These could be multi-digit numbers. Let's not be restricted to that. The spaces is what does them. Okay, so what's notes, not note. No, not whatever the heck that was. For const thing of or a line of lines for const values equals line dot split on the space, and now we have all of them. So for let equals 0, I less than values dot length I plus plus. Where'd my I go? Const if columns I, so if not columns I, oh, it's while not columns I, columns dot push empty arrays. Great, so you don't have one, just keep going till you got one. Great, you got one. Columns I dot push values I feel like that's right. I also feel like I've done something wrong. Let's look at our columns. And that's an infinite loop. Let's not do that. Let's do something. Cool, we're not gonna run any code. Who needs to run code anyway, right? That's... running code is lame. Cannot read properties of dot push. Okay, sure, I know that's an error. Oh, now you show up. Can you just log this line? Give me... Come on. Why are you running all those other ones? Just run this one. Jeez Louise. Great. Okay, we're not getting this logged. Please just run undefined B. Well, yeah, we know that. Could you console log something? Okay, console log no columns. So, let's see if we had an infinite loop here. Okay, we have it. 2, 3, 4, 5, 3, 4. Okay. 3, 4, 5, 2, 4, 5, 2, 3, 5, 2, 3, 4. Okay, that is exactly what I wanted. I want them as numbers, though. Let's fix that. Boop. We got it. Okay, so when we have our columns as numbers, now we get to play the game. I did all that for parsing. For let round less than or equal to, well, less than 10, round plus plus, and we're counting based on 1, so let's fix that. Round, okay, now let's determine index equals round modulo columns dot length. So let's make sure that column index is working. Oh great, you wanted to show up. Thanks, Wally. Drop that, hit at 1, 2, 3, 0. Okay, it needs to be negative 1. I really gotta get rid of that. Oh, where'd my 1 go? Is my num lock off? It is. Who did that? Not me. Okay, this is being logged. Okay, I don't know why I'm saying all this. Let's focus on my example. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay, great. We have the column index. So what we need to do, you always picked out the first one, right? And let's pick out the first one. Beginning of the column on its right. Okay, so first from each. So hold on, are these columns correct? Two, three, four, five. Oh no, those aren't columns, they're rows. No, what have I done? Oh, great. I mean, I have them, they're just doing the wrong thing. Equals, I guess it's this for first, what I need to do. Yeah, I need to iterate through this however many times there are, generate the 0th, 1th, 2th, and 4. So for let r equals 0, r less than length, r plus plus. For let c equals 0, c less than rows, c dot length, c plus plus. Column equals this. Column dot push. Rows are c. Columns dot push. Column. Do I have them all now? This would be the point you'd run, but that's fine. Drop that, save it, print it, run it. Not dot length. Rows C. Oh, because I'm using C in the thing. Whoops. Okay, that's a little on me, I guess. Probably is another error. Okay, and I'm seeing numbers 2, 3, 4, 5. 2, 3, 4, 5. 3, 4, 5, 2. 4, 5, 2, 3. Oh my goodness, it's literally the same in each direction. That is so confusing. Why would they do that? 4, 5, 2, 3, 5. Hello? Oh, okay. 4, 5, 2, 3, 5. Okay, I did have it wrong, which makes me feel less wasteful of that last minute. Boy, that was confusing. Okay, now that I have columns, Louise. Now I have the column index. So cost number, columns, column index, splice 0, not negative 0, 0, 1, 0. Congratulations, I got the thing. So I have you. Now I need to iterate through the second column. First on right, second on the left, until my iteration is the number. I assume I would circle if I continue to go through. Okay, so side equals left. That's dangerous, so we're writing a while loop, so while false, let's do that. Well, technically it's a 4. 4 let c clap equals 1. Clap equals number. Clap plus plus. Okay, now we need to determine where we're at. So I guess that's index and thing. So let row equals 0, and then as we go each of these. Okay, so let's clap as that, then it's the row that I insert at. It's kind of a tough one here, isn't it? The order of operations. Let's do this. Let's gonna be easier for me to track. Clap equals 0. It's technically row 1, row 0. We are while clap not equal the number. And well, it's not that, and we need to basically keep chugging along each time, adding one clap if columns. So I need to get a column. Hold on. Next column equals columns, column index plus 1. Great that. So this is the one I'm iterating through. I gotta check something real quick. I'm like, I'm back. Okay, so we have the next column. If next column row is 1. Well, hold on. It's not plus. Let row v equals 1. Row v, that means row v equals, well, it's times equals -1. If it's left, then it's right. Otherwise, if it's right, then it's left. There we go. So we have all that going there. Else, row plus equal row v. Right. I got that. Here comes the logic here. Okay, so basically this is going to get us to where we need to be for our row and our thing. In theory. Now the trick is it's not inserting at all, so I'm going to have to break on this one. And then console log row side and clap. Why are you not running? Oh, well, also, I know that part. But this should run. Jeez. Row 1, side left, clap 2. So 1, 2, row 1. Okay, yeah, that is technically correct. Okay, good. It's being a little less helpful, so I'm going to drop it for now. So we have that. So if we're on the left, then we need to splice into it at that index. So I'm just going to do it and see what happens. Splice row, deleting 0, adding number. And then I'm just going to log columns. Well, next column technically, because that's the one this will be splicing into, not the entire freaking thing. Okay, drop that, paste it, let's run it. Yes, I insert the correct position. I love it, I love it, I love it. Now the other one, so if you're on the other side, let's find this example, this is where it does it, right? Yeah, the circle around is going to be the trick. Row plus 1 plus left equals 0, 1. So let's drop that there. And it's going to be tricky because the visual isn't really giving it to me, but I can do it like this. Dot join console log like that. Let's see how that helps my eyes. It does not because I have a break. It also doesn't help because well, I'm adding the number, not the clap, but it happens to be. Okay, see if my eyes like it. Okay, it helps. We need to add that, and then we're going to see what this looks like. Okay, let's go through it. So 3 4 5 2 3 2 4 5. Okay, good. 4 5 2 3 4 5 3 2 3. Good. 5 2 3 4 5 2 3 4 4. Okay, good. Hey. Oh, we gotta go further, right? Next column index, modulo, columns length. The modulo doesn't work where you don't use it, idiot. Come on, let me in. Okay, good. Let's use our eyes again. 2 3 2 3. Oh, I'm supposed to go around 5. Well, there's no rounds on this thing. 2 3 4 4 2. Oh, wait. Last one is 5 2 3 4 4. 5 2 3 4 4 3 4 5 3 4 5 5. Oh, that's a horrible insertion, but it went to the right place. So now we just console log all the fronts, right? So we're doing all this. It should be working. So after we do all the round dancing, drop that. Results equals here. So results dot push columns dot max c0 dot deuce a b. I could have done this all at one, but it's fine. Plus b start from 0. My console log results. Might find me I get to return a result. Oh no, they're the digits of the numbers. Don't add them together. Concatenate them like a string, you crazy. There we go. The last one is 2 3 2 3. Okay, good. I want to spit out the 10th one. Turn results at -1 as a number. Congratulations. Boom. And congratulations. Boom. 3 2 3 3. Let's hope I got it right. Whoa, oh no. Oh no. It went down. Oh, this is really sad. Okay. Well, I do have something else I have to look at anyway. But this is, happens to the best of them. Happened to add enough code, I believe, once, but it's all good. Okay, I'm back. Let's see if the website came back on. Hey, awesome. I've got to re-off. That makes sense. It was just restarted. Quest 5 is where I'm going. Okay, my answer was this. Hey, I got it. Okay. Okay. Can repeat on one of the numbers for the 24th time. Oh no. Oh no, this is where you gotta be efficient, and we're doing some cycle detection. Oh no, this is bad. This is bad. So it's what round? Actually, these aren't big numbers, but this is only 2, so. Okay, solve quest 2. This is part 2, not quest 2, but who cares? Okay, I think I can do this though. Quest 2 until we find the 2024. So, const result counts regulations. So the results don't matter. It's the round and the thing. Okay, so result counts. So I guess I have to get result, which I have right here. Result counts. Result equals result counts result, or 0 plus 1. Let's get them parentheses in the right place. And I need to find out when it's 2024. So if result counts results equals 2024, then we break. So this isn't a for loop, this is a while loop. Wow. I mean, I can still write as a for loop. There we go. Then return. Well, I don't break. I need to return results count result. So what is that? The number of times. Wait, the number. So I have to multiply result times the round number. There you go. Result is a perfectly valid number. Why are you angry? Result. What's a number? No. Oh, it's a number when I do this. Okay, let's see. Part 2. Let's see if I got that part. No, that number is wrong. Okay, so round number shouts. So my logic is 2024. Did I goof that? Okay, let's just log what I did. Console log result counts result round. Maybe my game is wrong. I mean, if I have it working, then it should be infinite loopable, but I don't think I have a number. So let's log through the first 10 rounds. Boop, boop, boop. Put that there. I just want to see if they look like the first 10. Okay, 6, 3, 4, 5, 6, 2, 4, 5, 6, 2, 8, 5. Alright, so for the first 10, we had no duplicates. That's not good. It means it's not working. Dang it. Okay, sorry, I just need to step away for a sec. Let's figure out why my thing isn't working for the first 10. So once we hit 10, let's break.
I've shipped everywhere by now. As long as you can reliably get mail, I can get the shirt to you.
Okay, let's look at this. So 6, 3, 4, 5, 6, 2, 4, 5, 6, 2, 8, 5,
I don't ever do raffles that aren't international.
5, 2, 8, 4.
Sometimes we have sponsors that will require it, but I'll always try and do one myself.
5, 2, 8, 4. 4. this. Okay, I also just need to stop walking that because that's not helping my eyeballs.
Alright, I'm gonna stop it.
Drop
3,
that. Well, let's just drop that entirely.
Alright, I'm gonna grab all these
Log result.
Alright,
Okay, here they are.
picker.
63626262 5284. Yeah, that's where everything goes off the rails, and
Let's
then
talk about like such a simple app that
so 2 1 2.
it looks like everyone gets 2 votes. It looks like everyone has 2 votes.
So it's 5284. So from 6285.
3, 2, 1.
So I just need to look at the columns. This is painful. My thing's not doing the right thing.
Alright, Alex, yes. So I'm gonna give our shirt away as well.
Um,
I hope you'll have a wonderful day.
I think I need to look at all my columns.
Weekend. I'll see you back on Tuesday. It'll be really fun just to celebrate with
It's gonna be tough because there's no part 2 visualization for this.
Take care of yourself. You're a badass software engineer. Go out in the world and act like it.
325 6274 359. Whew. My mind is not even tracking this. Which means I need to walk it out. It'll be very painful. Let's do this. Alright, so the next one, the 2 is removed. We have a 2 up here, then it's 1, 2. According to the rules, it would get inserted. Well, the 6, I guess, goes up. Alright. So according to the rules, I think it gets inserted. Oh, Jesus, it's horrible. 2 gets inserted right there. Let me look at the rules. Yeah, so wherever you stop, you get inserted before them. So I stopped on the 7, so I inserted before them. Okay, great. Let's go to the next one. So we're pulling from 3, so you just got kicked out. But you're a 2 and you're a 7. You're back to these ones. 3 is up here. Give me some space. 1, 2, 3. So where does that get inserted? Let's look at the thing. Man, where's the one where we hit stuff at the end? 4, 5. So you get inserted at the bottom of that. So you get 4, 8, 3. So let me make sure 6, 2, 4, 5. So 6, 3, 4, 5. 6, 2, 4, 5. And let me make sure it's 4, 8, 3 in that column. 4, 8, 3, it's in that column. Dang it. Okay. On to the next one, and all these being separate is kind of killing me. 6, 2, 4, 5, 7, 8, 9, 3. I know the alignment's horrible, but nobody cares. Okay, great. So this is what we got right now. I just made a 6 instead of a 5. That's really gonna help me, isn't it? Okay, great. So now we're on. I need to add a column marker. C. So our C is here. Then our C went to there. Now our C is here. Which means our C will eventually move here, and I've just done the picture wrong. 6, 2, 4, 5, 6, 2, 4, 5, 7, 8, 9, 7, 8, 9. This 3 is supposed to be over here. There we go. So our next C will be here, so remove the 4 from there. These 2 move up. 1, 2, 3, 4. So it's. Don't do that. Don't do that. 5, 4, 9. Am I right? 5, 9, 4. Uh-oh. Okay. 1, 2, 3, 4. To where it goes. 6285. I'll make sure that's the right one. 6285, which when I pull the 5 out is why a 4 comes next instead of 9. Okay, I found it. So that's no problem. 594 549. Okay, this is it. This is it. So row, splicing into it. From the left, it's 0. From the right. So this is what I'm doing wrong. Let's see if it looks right. 594. Nope, still wrong. Okay, let me do a before and an after, because I've identified it. If I solve it, I'll be good. Let's drop that too, because I need to see. And let's drop this. Yeah, I can track by result which one it is. Okay, so it's 52 something 9. 5289. Yeah, 5289. That's the one you're problematic. Okay, so 5289. You failed. 6289. You went from 27. Hold on, those aren't my columns. Ah, here it is. Okay, 59594. So you're on the row 3. You're on clap 4. Side's the left. Excuse you. It's not. So I start on the left. I flipped around the other side. I flipped. I was supposed to flip. Okay, stop locking me into docs. Okay, let's find. I need to log all this stuff now. Yeah, this is what I do. I set it to that, and I move forward bit by bit. Okay, let's jump straight into this one because these logs are not giving me what I need. Yeah, I know you're not the one. So first one, second one, third one. Yeah, what number have I ripped out of? Column 01. Maybe column index 2 actually. Am I on the while loop? Oh, that's so horrible. Column index 2, 0, 1, 2. Okay, here we go. So we are going through 483, kinda. What? No. I'm gonna look at the columns. No, give me the columns. There we go. So 628573. God, this is even hard to look at. 6245. 6245. Yep. So I'm on round 3. 6345. 6245. We just did that. Now we're pulling out of 2, which we just did, which is why it's 83. We have the number 4. We're going to try to insert it in the right place. Okay, here we go. So we have one clap. I'm on row 1. So my 4. Okay, let's get out of the equation. So one clap was there. Now we're here. It's our second clap. It's not 4. Row and row V. So we're going to go down a row. Where the hell did we just go down to? What row are we on? 0, 1, 2. What the heck is row V? Row V is 1. So columns. It's no, I need to be looking at next. How has this ever worked for me? I have no idea how this even works right now, as my eyeballs are looking at it. Come on, come on. Where's that 4 coming in? 549. Okay, this might be it. This might be it. Drop all this stuff. Drop all this stuff. Kill it all. Kill it all. Don't kill it all. Let's just run for the console logs. Give me number. I love you. I love you. Now I gotta kill the logs. I'm really curious what part 3 is now, because I have been roughing it so far. Did I put my notes in there for part 3? Part 2? No, I haven't. I need to go get my new input. Please don't be big numbers. Please don't be big numbers. Big numbers. Ooh, computationally large numbers too. Yeah, I'm doing no cycle detection at all in my life. Okay, this is where the suck begins. So the fun part is that if I'm lucky, I can do this. So I'm spinning off another one. Q.ts, drop that, bring over our friend. Because it's possible you can brute force these. And I'm just gonna let this process do that. Oh, did I just paste in a whole bunch of white space? Okay, I pasted it in. It's not in the actual original. So let's clean this up before I run my brute. And let me see if I can find any quick optimizations here. This is the grossest thing ever. I don't think that's too unoptimized. And this console log's gonna eat me alive. I mean, this dancing song is a thing that happens. If I find real cycles, then I can fast forward, but I'm not looking to do that now. I'm looking to just do badness. Ooh, the splicing though, this is horrible. If I invert these columns, so if I'm not splicing, I'm popping off the end, that would be a lot better. I'm still splicing to insert, but I won't be splicing to exit. And that would invert all of this dance logic, so let's not do that. Let's just go for the badness. CD05 npx, let me in, npx tsx q.ts, and say goodbye to my... Did I not run it? No, it's right here. Hi. Oh, is it? It completed. That's what happened. The dumb thing completed while I've been babbling, being like, it's gonna take a long time. And it was just like, nope. When you're not running through Jest, I'm pretty darn fast. Dang it. Assuming the dance will never end, the highest number. Oh, man, you really want me to do good math now, aren't you? To go on forever, the highest number shouted. Wait, isn't that the highest combinatrix? 6584. Hold on. The highest number shouted would be 9876 if it was just combinatrix, but it's not. Ooh, this is painful. Okay, so I'm just gonna do this over here since I know it's not gonna compute over there. Largest, paste, got trim. So let's make up a cool function called largest, which is just gonna run. It's gonna eat my computer alive, but it'll do. So, hopefully I don't have to go into big int territory. It's a pretty big looking number, but it looks fine enough. If around modulo, I want to see how much this one hits. Okay, it hits quite a few times, and that's not the condition I wanted. What every thousandth? Okay, good. Let's add 2 more zeros to it. A little less popular. Okay, we're still doing lots of runs. I think we're in the billions now. Okay, it's a little bit slow for my taste. Let's jump it by 1 factor. Still high for my taste. 1 more factor. Boy, I really added a lot of zeros on there. Okay, this is successful enough. Console log math.max object.values. Wait a minute. The highest number shouted. That would be the keys. Keys, which will all need to be mapped to a number. God, that's kind of painful. That's inefficient as all heck. You just want the largest result. Let big R equals number dot min safe integer. Probably add that factor back on there. If result greater than big R equals result. Console log big R. Yeah, let's see if I can re-add that factor. It's not wasting all that memory. Okay, we're actually still chugging. I'm gonna go for that one number. That's a good looking number. 5 minutes. It's worth the price. Ah, okay, 5 minutes. So now we're just computationally beating the heck out of it. Assuming my dance is still correct. Yeah, this isn't going to do well if I don't get lucky. Maybe I get lucky. Make sure I didn't paste a space. Okay, it's no spaceless. Okay, highest possible number that can appear at the round of the yellow dance. We're doing cycle detection. That's what we need to do. But it's not cycle detection the entire thing. It's cycle detection the state of the array. So let's go back into test mode, because that's where I'm going to find it. Just stop. Okay, just is lost forever. That's fine. So let's break this into a 3. As soon as I find the cycle, I've done it before, we can fast forward based on it. Well, I mean, if we find a cycle, then by the rules of a cycle, then we'll never get out of it. So that's not possible for this part 3. Yeah, so cycle detection would have really helped for part 2. I don't think part 3 is going to get helped by cycle detection. That's kind of ironic. Because I was just about to be like, it's time to detect cycles, and, no. Did you find a new number? No. You found the one number, which is kind of concerning. You're not finding any bigger ones. But that is after like 100 million, so. Interesting. I mean, it's only day 5 and I might be getting stumped here. Don't open that. You still going? Okay. I'm gonna see if I'm the only idiot here. Okay. So there are people doing it. 54, 30 minutes. Oof. Yeah, I am struggling. Boy, man-eating ape is really up there. Who are they? What are they doing it in? Does this go? No, great, this is Rust. Huh, neat. Wait a minute, what the heck? What am I looking at? Okay, this makes more sense. Okay. I mean, if you're writing it in Rust, you might get better speeds than this. This is what I'm supposed to be doing, right? Highest number that can appear at the end of a round. Assuming the dance never end, be 6584. And I got that, right, in my... Oh, I skipped it, so I guess I didn't get that. Let's run that in this one. A copy of this one, I guess. Got a little ahead of myself there. What the heck's the name of this stupid function? What did I call you? Largest. Oh no! Oh no! Okay, kill it, kill it, kill it, kill it, kill it with fire. I goofed. I changed this behavior to that of largest, and I never. The idiot was I all along. Oh no. Okay, let's do the thing I wanted to do. Let's put it in the real one. Jeez, I'm an idiot. No, not that number. This number. Watch, it's gonna be like instantly there, right? Get to your billion or whatever. 6584. Yeah, it's there. Drop it. Give me my bits. The idiot was I. First one might be it. So I'm gonna wait. Well, I never actually got anything a bit higher than this. Don't terminate. Are you actually doing a lot of thinking right now? Oh, jeez. Oh. I might drop a 0 to get me better results. Drop 2 zeros because I'm impatient. Okay, that's a good looking number. I'm gonna go with it. It's a pretty stable looking number too. Yes! Haha, the power of brute force compels you. Honestly, not that big of a number. What are we at? Million? We're sub-million. That's computable with bad math, obviously. But yeah, there we go. So we'll start with the first one. So yeah, parsing this into arrays of columns. I did a bit of a roundabout way. First I parsed them as rows, and then I iterated through each and rebuilt the columns. That can definitely be done in one iteration. The next part is the actual dance, which it caught me for a loop initially, but you track which round you are, and that round modulo by the number of columns tells you which column. But it's really just column 0, 1, 2, 3, 0, 1, 2, 3, so you just keep going, and you always are targeting the next column for where you're putting the number. So you steal from the top of this, and then you insert at the clap index, but not really because it changes. So 1, 2, so we insert after, well, before the 4. And then you output the name words at the top. Same thing here. The tricky part is that if you hit the end, here it is, 3, and you retry that number again from the other side. If you didn't do this, there'd be no opportunity to go into the end of the array right here. There'd be no opportunity for that. So that's why you got to process from the other side. But this time, the possibility of going bottom left, in which case we do, and we insert accordingly. And we do this for every number of rounds. First one was what is the number at the top of all these columns of the 10th round. Second one, we go through and we count how many occurrences we get of this. I've seen this in an admin of code once. Then we output the multiplication of the round and the number of times we've seen that number. We do multiples of numbers. Second one is just run it for a long time or do cool math and detect when you get like the highest possible number, which is not just combinatrix of the numbers by a very special arrangement apparently. Stop running that. And yeah, all of this is done here by getting the top of this one, splicing out the 0th number, get the column index by moduloing the round, get the next column by adding 1 to it and moduloing that to wrap around. This was the tricky bit that I realize is completely broken, but it's functional, so I'm going to commit it as it is and fix it later. We check we basically go out of bounds for that column, and if so, then we change directions and change sides, but we don't increment. That's the trick. This allows us to double process a single row index from both sides. Yeah, we just keep doing this until we hit the number. Again, this could have been done as a for loop. Honestly, my rewrite's going to be as a for loop. And then you splice at that index, either at it or after it, depending on which side you are. And then you grab all the 0th, or all the ones at the beginning of our column or the top of our column, smash them together, convert it to a number, or you don't, you convert it to a number later. Second one was just the same thing, but counting the number of times you've seen each result in a map. Once you find the 2024th instance of a result, do your cool multiplication. And the third one, which is living over here right now, we just ran it a lot. Get track of the largest result, and every now and then we just logged it. The more optimal probably would have been logging it as it changed. So let me actually do that. I won't commit it like this. So log big R. We're going to see a lot of initial logs, and then it slowed down like heck. Or not, it'll slow down pretty quickly, right? And then seeing like, hey, it's been a few minutes will be your sign that, yeah, we're good enough. So that would probably be a max round limit, honestly. Or be a cycle detection. If you hit a cycle, then yeah, you also give up. So that would probably be the real one, implementing cycle detection. But yeah, that's Everyday Codes Quest 5. Hope it's been a pleasure. Hello. Today I will be cleaning up my, we're refactoring mainly, my everyday code solution. First, I guess I'll start with 5, because I never really got it finished. I finished the problem, but I was like, good enough, and then I moved on with my life. So I'm just going to move this solution from the other file into the real file, in my test file. So I'm trying to remember, what did I do? What did past me do? Okay, first let's start with our test cases. Okay, so part 3 example, this, which is supposed to be outputting this number. Part 3 notes is this, which is supposed to be outputting this number. There we go. Let's see if I got the part 2 expecteds correct. Oh wait, there it is. Part 2, I did not put that number in. Was moving fast. Part 2 for this one. Yep, I did have the example. Part 1, did I put in my expected? I didn't. Okay, so those are set as they should be. Solve quest 2. Yeah, I think I'm just going to bring over the 3. Again, making no functional changes, just organizing the files. I think solve quest 3 is this one. Yeah, that should be it, 'cause it's at the bottom. So let's go up there, drop that, commit it. Three. Do I already have a 3 in here? Oh, I do. Not. Just gonna pretend that doesn't exist. Okay, let's see if we can run all of this. Okay, I guess I still got some consoles in there. Part 1, Part 2. Ooh, we still got some consoles in there. I'm not gonna get rid of them. I mean, I'm gonna get rid of them. I'm not going to delete them specifically. I guess serious duplication going on here. Okay, here we go. Yeah, and every time it gets bigger, we log it. Ooh, that's right. We never actually end. I guess I need to have this thing end. Because right now it's just an infinite loop. Trying to remember what I physically did that was good enough. Oh yeah, part 2 finished. Good. Oh, that's right. It's only showing the greens for the ones, right? 1, 2, 3. Yep. Okay. So the slightest of modifications to make this one work. I think it's just a 10-second timer. Be like, it's been 10 seconds. You haven't found nothing better. It's good enough. Big R. Found equals date.now. Found equals date.now. And yeah, I do need the log in there. Well, the log's for debugging. Keep that in there for now. If date.now minus last found greater than 1 minute. Let's go 10 seconds. There we go. So we wait 10 seconds basically to find our answer. So let's... Part 2 still works. Part 1 still works. Let's look for the example. So we're going to have a 10-second run on this. And then we'll get our number. Again, many more optimal ways of doing this. But that's not what we're targeting right now. So 10-second run on our actual input. And if this works, we commit away. Why is get not working? Oh no, it is, just not showing the thing. Did it pass? Where are my tests? It passed. Good enough. Okay, which means we can stage that and go to our scratch pad, which has the exact same function I copied over. Yeah, this is literally part 2, so I can drop that. Drop that. There we go, initial 05. And now that that is done, look at my list. Yep, we've committed everyday codes 5. There's refactoring for 5, 4, and 3. Hello, hello, hello. Today I'm here to refactor Everybody Codes Quest 5 solution. This is it. Yep, it's a lot. There's a lot in here. There's a lot of duplicate stuff. There's a lot of scrolling stuff. It's a lot. As a reminder, it's this weird pseudo-random clapping dance which just did not map mentally. Very archaic process. Not archaic, just unnatural, it felt. So you just pulled so first you kept track of which column you're pulling things, you pull something out, you go through it. Once you hit the ith iteration, which is whatever this number is, so it hits 2, it gets inserted back into this column. based on some stuff. If it's on the left side, it inserts in a certain place. If it's on the right side, it inserts in a certain place. It's all very great and complicated, and I already explained it previous segment. You figure out what happens at the 10th round. I think this one is the 2024th round. Oh no, it's for if you see something 2024 times, because this is cyclic in nature. Or it's repetitive, not necessarily cyclic. And part 3, I think, is just do it a really long time and see what the biggest one is. So, and I did some code for that. We have one function for one function for another, one function not for 3, and one function really for 3. So, it's all here, and we are going to clean it up. Ignore those changes. So, let me see what commonalities we have. We have the parsing, which I'm doing double because I did it the wrong way first. That can be cleaned up. We have the actual dancing logic, which I have here functional. Parsing again. Dancing again. Counting the number of times you've seen a result. So that's the addition of 2. This one says not, so I'm just going to straight up delete it. If it's not used, we don't need it. Now for 3, not Cree, we do the dancing, then we track the biggest one we've seen. Okay, so it looks like we have 3 things we're all returning, and it's all based at a different end result. So if we see the largest number in a long time when we return it, if we see something X number of times, this 2024 times, we return some math, and lastly, we just return the 10th one. So those can be 3 outputs of the base function. The 10th one, the one that appears X times, both the result and the round, and finally, the one that hasn't changed in 10 seconds. Which is a weird way of doing this one, but we'll think of optimizations on it later. So function, do the dance. We'll think of something better for this function. What do we call this? Pseudo-random clap dance. Nope. Where is... I don't know why that's emoji there. Okay, weird. Pseudo... random... clap... dance. There we go. What inputs do we got? We just take notes. And then let's just take over. Again, we're just going to make it work. We'll make it right. And we'll make it pretty of our singular usage function later. So yeah, we need for this one to track all these bits. And we'll keep the 10 seconds on there. And then for the other ones, or part 2, we kind of need this results count and this logic here. It's just a dictionary? Yeah, it's just a dictionary or an object out there. So let's have that going. Results counts, sure thing. And the final one is just, hey, what'd you get on round 10? So it's just the 10th result. Okay, I think I can just literally write that into this. So if round equals 10, so we're doing 1 index. So it's going to be 1 or 10. Where do we do it up here? Nope, I'm looking at the wrong one. So if triple equals 10, then that's the one we're looking for. Okay, great. All up 10th result equals 0. And here we go. Oh, hey, look, that's my old code from there. Equals 10. 10th result equals. How do I get the numeric result? It's right there. Lovely. So we have all the pieces here. Let's start using them, or returning them rather. So, you're not going to return here. Say whatever appears 2024th result. Weird. Um, 2024th. Trying to think. We need result and the round. Thing. Nope, not a keyboard event. Result round. Sure. And here we go. 2024 thing equals result round. We have both information. And this is our break. So once we break, we're going to return a bunch of random stuff. We're going to return the big R, the 2024 thing, and the 10th result. Seems weird, seems arbitrary. Don't worry about it. And then if we really want, we can chuck 3 booleans on here or an enum onto here to only care about one of these at once. But let's figure this out first. So I think we're doing everything. We only stop when we have blast found something in 10 seconds, which is what the most difficult one needs. So let's start using these instead of this here. So return notes, and we want the big R. And here we want to multiply result by round. Well, I just skipped it. Return notes dot 10th results. Let's get back down here. Cost result round equals notes dot 20 term result times round, which I didn't put in here for some reason. You know, it'd be too easy. Okay, I think that is capturing the information. I mean, why think when we can prove? Quest 5, part 1. Ah, dang, that 10-second delay. Really painful. Yeah, I think I'm gonna booleanize these so it's not all one gross thing. Or I can try and make 3 different functions. Because I think it can be broken out. Because if we look at it, the dance... Yeah, I think this can be broken into 3 functions. So it's 10, 20, 30, 40, 50, 60. Sure, it's going to be a 60-second run. Boo-hoo. I'll continue try making it into 1, which I don't have to try. I succeeded. And then I'll split it back into 3. Yeah, keep going. There we go. Solve quest. Quest 1. That looks weird. Oh yeah, I guess I just always name it like this. So I am the weird one. Okay. So let's start doing this part. Function parse columns of people. Participants, dancers, jeez. Okay, which one failed? Part 3, which had the 10-second delay. Okay, so get rid of that. Wait, part 2 failed. Expected, but actual. Oh no. Why did it say part 3 is up there? This is the part 3 section. Do I have multiple part 3s? Is that what's up? Because I know there's a typo in one of my Oh, part 2 has failed. Is it just not pointing to the correct line? It's not pointing to the correct line because I was moving stuff. Okay, so I broke part 2. So let's stop everything. Halt the presses. Bring back our part 2. And this one. Here we go. So results count equals the thing or -1. If it's 2024, return result times round. Okay, let's see what I broke about that. Let's count. You just keep going. So this one just goes for 10 seconds. What are your bounding conditions? Your conditions is you've seen something 2024 times. So if I don't see it 2024 times, so I have the potential to break. So if this and 2024 thing result, basically, if we got something, then you can break, but no sooner. Okay, let's see how part 2 does once more. And I really should think of a better way than this 10-second, because I am already dying from this. Wow, okay, let's put part 2 back. I made the unfortunate assumption of assuming the code worked before I started changing it. That might have been wrong. No, it does work. Okay, put it back. Did the dance change? It's possible that I made a fix to the dance that wasn't necessary. Sounds unlikely, but I don't know. Results count. Rounds 10. Ooh, the first one. There we go. And not results. Basically, we want the first one, not just like the latest one that hit 2024. I got it. That was it. Yeah, now I can continue on with my cool function. After I wait patiently. There we go. Okay. Function parse dancer columns notes string. It's basically this. Right, so this is what I'm doing. Let's I'm gonna do this on part 1. I just want this logged out and then immediately killed. So let's do const columns with parse answer columns notes turn 5. Nobody cares. Okay, let's hit it. 2, 3, 4, 5. The tricky one is that they're in the same direction on both, so I can't tell because it's literally a certain kind of matrix. Is part 2 different? Yes, part 2 is different. I'm gonna use that one, not the real one, please. Cannot do structures. Okay, 2, 6, 3, 7, 4, 8, 5, 9. 2, 6, 3, 7, 4, 8, 5, 9. I got it. Okay, so that is doing exactly what I expect. Let's get this working. You know what? That'll be easier because I will take it straight to there. There we go. Love it. Okay, so we have this. We're doing it the jankest way in the world. Building rows and accessing the rows to get the columns. I should be able to use the lines. Let's see about that. Yikes. Oh, no. There's the weird spacing in between, right? Yeah. Did they ever go to multi-digit? Because that was my concern. Okay, they do go to multi-digit. Are they all the same digit length, though? Uh-huh. So if they're 4, they're all 4. If they're 2, they're all 2. This is actually very good. I can use that to calculate accordingly. plus digit count equals lines 0 dot match all the digits, I think, and then dot length. I think that'll what I'm looking for. 1. I mean, that is what I'm looking for. Let me try part 3 because you got bigger stuff in you. Part 3, I thought you had longer ones. Oh, the singles are all keeping it the same. Okay, fine. The notes. What do you go? 1. Nope, I got it wrong. Okay, let's just log the match itself. I'm not accessing the regex magic inside enough. There we go. Well, no, we don't go nowhere. Oh, it's 0 dot length. Whoops daisy. We got it. Okay, great. So now that we have the digit count, what we can do is access slice. So the digit count is going to influence the offset of our columns. So I plus equal. Okay, all this scrolling is destroying my brain. Let me get down. Oh, jump down to it, please. There we go. Jump down and bring an example up with me. Here we go. So yeah, the row doesn't matter. The column does. So we start at 0, and we get digit count number of digits, and then we increment by not 1, but at minimum 2. Because 2 will put me in the next one, but then we add the number of digits minus 1. Gotcha. Plus equal 2 plus digit count minus 1. Now, my column, I mean, it's kind of going to be visually obvious. Well, I'll need to slice here. The slice from C, and then the index to N, C plus digit count dot length. No, it's digit count, that's a number. What's the worst that could happen? 2, 3, 4, 5, 6, 7, 8, 9. That's a funny output. 2, 3, 4, 5, 6, 7, 8, 9. So those are rows, not columns. So I've mastered the art of accessing the numbers. Is it working for the 3? I mean, what's your first? 22, 94, 27. 22, okay, yeah, so I'm accessing the rows. Great, I've done the same thing I did in the beginning. Access the wrong bits. So for every row, there's that row and grab that column. I think I just need to invert these. And then That doesn't feel right. It's the worst that could happen. That could happen. Okay, let's invert it again. Pull it back where it was actually running. Okay, so let's look. We have multiple of these. We want to be on the 0, 1, 2th row and be building a column. So we do want this on the inside. For our column, we do want it to be on this. I got rid of it. I should have went 0 length. And let's bring our column back up to that level. Feeling a little better about that one. 26, 37, 48, 59. I think that's it. 26, 37, 48, 59. Boom, we got it. And now we have this. We would just like it as a number, good sir. Okay, I think this is it. We can drop the rows entirely. And the columns, we kind of need those. We're returning those. Digit counts, built-in lines, we need those. Yeah, so I think this will work. I've still got our 10 seconds to wait. We're not calling anything. We're just doing it and being like, I sure hope you like it. So we got our 10 seconds to wait here. Right, so that is our parsing. Let's drop all the old code now. It was nice knowing you. When that old code is dropped, I'm looking at double old code from part 2 that I don't need anymore. There we go. Oh, let me. That is an alert that I can ignore. Love it. Okay, back to it. Okay, so we have this parse dancer columns. Boom, we're done. All these random things. We just need to perform the dance, and this will give me the result. So let's break that function out. Function. Do we call this a round? Dance around. Execute round. Okay, what things do you need? So you need round, you need columns, you need round and columns. Okay. And then you return the result. EZ. I love it. Get rid of all this complicated bits here. We just have the weird result collecting and parsing bits. I'm very confident in that, but let's run it just to be sure. So this is where I think making a single function that does all three of these is not in our best interest. Because we've taken away the complicated part. All that's left is the literally per problem or per part unique handling of outputs, like getting the results. So yeah, we're not going for single function that does all the things. We're going for similar functionality, broken out into different functions, and then the unique things is where, they diverge, they do their job. So let's take part 3 and let's do its big R. Big R. If I really wanted to, I can even encapsulate this in a function with a callback for like, hey, something to do every round. Here's a do something if you want to break. That sounds really overly complicated though. Here's the thing, you don't need to break, you can just straight up return your big R. It's this conditional, yep, and then the rest of it, you don't have the data, so you don't do any of that. I like how clear this gets. Love it. Let's do another dice. What's on my clipboard? Okay, I've lost it. Grab it again for round 2. Yep, we never return there. We always return in here. Return result times round. Drop it all. Drop that. Drop the 10th round. Keep the results. I'm not tracking the big one or those. Or those. Or those. Or that. Look how simple this is getting. Beautiful. Okay, one more version. Let's grab it. Part 1, I never got rid of these bits. That's okay, we're doing it now. And if it's the 1, then we return the 10th result. We get rid of everything else. Literally everything else. Okay, I like this. Our 10-second one's still an annoying 10-second one, but we can run everything else without the pain of it. course him, because he's going to be painful. Now, we could go that one step further. I'm tempted to do it. Function solve quest CB. Hold on, let me check something real quick. Is that another alert? Oh, okay. Oh, they're just checking other things. Let me read this just really quickly. Cool. Sorry, I'll be back. Okay, I'm good. Oh, I almost knocked over the router. Okay, solve notes, string CB, result. Well, result is number and void or number. It's not void or number, it's undefined or number. Either return a number or you return nothing. So let's do the dance. Do the dance. Do the dance. Boom. We got our columns. Do we need anything else? I don't think so. We just need this. I've effectively am defining a reduce with an accumulator here, if you think about it. For each result. Yeah, okay. So it's going to be const return value equals for each. No. Feels like weird calling it this. For we'll call back again. I don't have a good name for it. If return value not equal undefined, return value. Boom. Okay, we love it. Let's try it. Guess I've learned that. So yeah, we know all these work. That's what we love about it. So if we return solve quest CB, pass it notes, we pass it. Dang it, we also need the round. Okay, we're passing two things to it. It's not the end of the world, but it's starting to get additive. Round equals 10 or undefined. Yeah, that's going to work for part one. I know it. Easy. Let's go to part two. I'm not saying I'm doing this. I just want to see if this is a doable. So we do need to keep some outside stuff. So kind of like an accumulator. Results count. So it's a multi-line thing here. We do need the round in this one. Cool. Count, and then this conditional logic here. Boop. Bam. I believe that's good for part two. That it is. I think I'm liking this. You know, I know it's not as pure as these, but I don't know, it's scratching a niche. I'm liking it. We just need the result. That's right. We just keep two variables outside to this one. We do this logic, ba-da-ba, boop. Cannot redeclare. Oh, it's because you're down here. I think I just said goodbye to the old way. Boom, this works. Okay. For each dance round, then result in your CB, and yeah, we get this on 10 seconds. Still no solution to that one. I don't know what I'm looking for, but I know it's not this. You have to get rid of our do everything function. There's something here. Maybe it's a second. We can squirm by just within a second. If the real one, that's the trick. Okay, so we're looking at within a second. This is runtime based though. So we want like n number of rounds before it doesn't change. If we do cycle detection, then it'll be when we detect a cycle. Cycle detection. Yeah, let's go for cycle detection. Const scene states equals new set. So yeah, this is one we're gonna have to expose one more piece of information here. It's I know we're getting painful. But if this isn't useful, I will unexpose it. Okay, here we go. Let's do this. Boy, I forgot how few lines we have to go now. So let's just comment out all these bits. They were very cool. Most of these bits, not all these bits. And here we go. Void. Huh, I never return a thing. Thanks, TypeScript. Keeping me honest. If scene states includes const state equals JSON stringify my current columns, which are way up here. Nope, third argument rather. Includes current state, return big on, else scene states add current state, and it's has, not includes. Now this is gonna hurt on the memory, but we're paying for it to get time. Yeah, this is the way of doing it. Now, JSON stringifying it, I'm not saying that's the best way of doing it. Biggest result. Whoa, I lost my F2. Highest result. And then, yeah, let's just do the cool thing. Whoa, mouse only went, I nearly went off the edge again. Let's hit it all. Boom. Okay, I'm loving it. So, we had to get more data, which, you know what? I'm almost concerned just about shoving in an object, but then that's going to be even more memory expensive because we're making an object every time. So I think we're fine just here. I do want to see if I can squeeze some betterness out of this. Because effectively, I'm serializing a matrix. This isn't the worst way I've seen to serialize a matrix, honestly. Especially since it's not just the values, the order, the positions, it's all of them. They all matters. I don't actually need the content, I just need a deterministic way to generate an identifier for this. Don't mind me. Just importing crypto here because I'm about to make me an MD5. How do I do MD5? Oh, wait a minute. I still need to stringify that thing. Fine. JSON's fine. JSON is fine. JSON is good enough. I think this is honestly a fine way of doing it too. If you've seen it, return it. Otherwise, drop it. Let me see how I like this look. They belong together. So yeah, the else looks better to my eyes. Okay, so for each dance round, we have all the solves. Let's bring the solves down here, bring them down here, paste them. I am loving it. So now that we have cleaned up code, let's go through it. So we have our cool little for each dance round. First, we parse the columns out of the notes. We split it into multiple lines of strings. For each of those, we calculate how many digits are in the first number, a little bit of regex magic. Then we create an array of columns. Then we go through every column, which if I were to go back here, so we're counting through the length of the 0th string. So the length of this string. So we're going through each one and we're always adding 2. So we go from 0 to the 2th index to the 4th index. But then what we're doing is we're adding the number of digits. So from 0 to the 3rd index, but then we're subtracting 1 because I'm off by one thing. So then we're going back here. This works when there are multiple 2, 3, 4, whatever number of digits our numbers are made out of. This handles those. Next, we're building a column, and for every row, so this is all of these, we're saying, okay, give me the ith row, or the rth row, so it's this row, and slice from the starting number to the ending number, which could be the same one, but for multi-digit characters, it's the index where it ends, and give me that number. And then go to the next row, and give me the exact same column, and the exact same column, and the exact same column. And then I go to the next column, +2 minus digits count, or +2 plus digits count minus 1, and the same column, and the same column, and the same column. We get all that. Use a little unary operator to get it as a number. Add it to our array. Add it to our array. Add our array to our columns array, making ourselves a little matrix, and we return that. The next stage is we start at round 1 and we just keep running. So this is effectively a while loop, but we're using for loop syntax to declare a variable and keep it running and just keep incrementing that variable. And then we call our callback with the result, the number of the round, and all of our columns. If our callback is returned with something that's not undefined, we return it and we exit the loop. Note that we're checking for something that isn't undefined because a result of 0, for example, would be falsy and would not be returned if we just did a check like this. We're going to make it, it's going to work in our case because we don't have any zeros that are the actual result, but it's safer this way. Finally, our dance round. This is the one that does the tough, weird logic that got me stuck, but I eventually got through. So, we get the index of the column we're dancing on, which remember, it's this column, and then this column, and then this column, and then this column, and then we're back around to the first one. So it's round -1, because our rounds are 1 offset, so we go back 1. We use the modulus operator to wrap the number around somewhere within this 0 range, 0, 1, 2, or 3. Then we get the number from that column by using the splice operator to say, hey, start the first one, which is this 2. Give me one character, and it removes it from the array, so it's destructive. Splice is destructive, not slice, which is non-destructive. And it returns an array, so we got to get the 0th number out of it. And then we're like, hey, what's the next column we're going to touch, which is column index +1. It's always the column to the right. Modulo again, just in case we're at this column, and the next column would be over here. We got a modulo again. And then our fun stuff. So we're always starting on the left with our little dance thing. Our velocity is basically like our direction of like where we're looking next. So we're starting 1, which is positive, like we're going down. When we go up, this is -1. The actual current row we're looking at, that's going to go from 0 to however many rows there are, and that could start to decrement again. So it's going to go up and down. And then the number of the claps. That's just the iteration for our thing, which I'm looking at now. Clap equals 1, clap not equal number, clap plus plus. Yeah, could just do that. Why is it angry? Oh, I'm missing some curlies. And the clap was in the front, which means our clap needs to start at 1. Well, our clap is at the front, so it starts at 2, right? Let's see that work. Oh no. Oh no, 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 no. Put it back. Put it back. Put it back. Put it back. It's a possibility that the clap is instantly the number. But so those are in an infinite loop right now. So yeah, we start off at 1 because we could be looking literally at a 1. And then we increment at the beginning to get us to 2, and we go through everything accordingly. I'm trying to see. So, well, this is dead. Let me reload. Because I believe I can make this a for loop, and I would rather make it a for loop. People understand for loops better than while loops, unfortunately. Let me come on back to testing land. Okay, now that I fixed it, it works, right? Okay, great. It's back to working. I think I can do this. For let clap equals 1, clap not equal number, clap plus plus. So the problem with this is that before we start at 1, we do the check, we increment. We're starting at 1, we're doing stuff. No, we're starting at 1, we're doing the check, we're doing stuff, and then we're incrementing. So basically this do stuff step just got moved in our order of operations a little differently. So we kind of need to... I mean, we can just try it. Let's see what's the worst that can... Ignore everything I just said. It's perfectly fine. This dance, it threw me for a loop the day of, so I won't worry too much about it. Our row, yeah, we need that outside. Our row velocity, can shove that inside, honestly. Nobody cares about it. Do what you want. The side, that's important. That flips us left or right. It's also our row velocity. Let's see if we can use side as row velocity. Let's make sure I didn't break nothing first. Great, so plus side, whoa. Plus side equals left 1 or minus 1. Yeah, so let's see if that one's functional. Okay, great. Let's give it the real run. It's only a second and a half. Okay, great. Now can I use that down here? I'm actually also doing that, and if so, boom, I just eliminated that variable. It's a little harder to read, but there's less to read. So if I'm just using the side as... So here I'm using it to calculate row velocity. Here I'm using it to calculate which one I'm slicing out of. Okay. 1 or -1. 0 or 1. So yeah, I could destructure it further and be like, great, side is just a number, and then rename side to something else. But then it would be hard to abstract here. I think this is sufficient. You could also just go and fully use it as a cause on let on left equals true, and then use that instead. It makes these a little easier to read. On left, there we go. On left equals not on left. Drop this side, we just use, it's a boolean, so how about we treat it like a boolean instead of an enum, we switch between two different values. Yeah, I like that a little bit better. We can calculate row v here, cost row v, and then we can just use it here, make it derivative. I like that better. Yeah, those parentheses can go. Yeah, the if else is good. It feels weird having the quote non-base case up on the front. So let's just do an if it's a value. Then we do it, else we flip. Yes, I know we're opening the door for zeros here. I don't think we have zeros. Nice. So I flip that around. I need the row index because, yeah, I need that. On left, I need that. Yes. Next column, I need that. Column. Do I ever need the column? I never do. I mean, I need it to access a thing. I never need the actual column. Okay, I'm pretty happy with this. Attempt to do one more renaming on this to get even closer. So if I could just go back to row velocity, then it loses this. Keep that, keep that. Row velocity equals times row velocity minus 1. This is the only one that gets a little harder to read. Let's go for it. So row v equals 1 times equal minus 1. Right, so it's going to be row v equals 1. This or that. I think this is a little bit better. Maybe row velocity isn't the right direction. Row offset, row change, row direction. Row dir, how about that? And then now these two kind of look like they belong to each other. Yeah, we do the dance, we get our information, we do our dance, do our putting in there. Yeah, I'm liking this, Okay, now let's, so, all of that I was explaining, I ended up doing a refactor of this. This does a round of the dance, moving you along until you hit your clap number. If you're on a real value, then you just keep going down. As soon as you're at the end, you turn around, go to the other side of the column, which visually they represent right here. So you're on the left side, that's your direction is 1. Oh hey, I reached the end, there's nothing more here. My direction is -1. I do not move forward because I can still do stuff here this round. And then I move forward next round accordingly. Then this is used to splice it into the correct position, because if you're going down vertically on the left, then whenever your number is called up, you can see it goes like, if you were to point to the space it was filling in, it was going upright. But when you wrap around and you go in, you go down left, not up left. So it's just an off by 1 thing of where you are inserting yourself. So now that we have the dance out of the way, let's go back to our 1, 2, and 3. So for the first part, once you get to the 10th round, just return the result. That's all it asks for us. For our next one, it's asking us to count how many times each result has come up, which we're doing with this object out here, like a hash map. We're saying the count of this result is the count of this result last time, or if it's the first time it's seen, 0, a +1. And if that count happens to be 2024, which is our magic number, we return the result times the round, which is the answer to part 2. Part 3 now, we keep track of the highest result we've ever seen, which we initialize to the lowest number we possibly can, and, well, we keep track of the highest result we've ever seen. But as soon as we have seen a state of columns that we have seen before, which is the laziest form of cycle detection, which is basically saying we have not only been here before, because that's one part of it, we have been here before, and our state is identical. So, like, not only is the number at the beginning of each column the same, that means, like, we've seen this result before, 3255, but so are all the values in the columns, the order of the values in the column, like everything below here is also identical, which means, because this is a deterministic game or a process, there's no math.random here, we will never, like, we are in a cycle. We can never escape this cycle. We will just keep going, keep doing this over and over again. So we get the current state, we represent it as a string using JSON the laziest way possible, and we see if we've seen it before. So, like, how are we in a cycle? If we're in a cycle, then there is no way for us to generate a higher result than one we've seen. Well, let's abandon it. If we're not in a cycle, well, let's just record the current state, right? We might come back to it. So this is rather, again, we have the exit case front, which I don't like because it makes it reading a little weird. There we go. So if we haven't been here before, record our current state. But if we have been here before, then boom, you're in the cycle. Happy day. And that is my refactoring of Everybody Codes Quest 5. Pleasure as always. Toodaloo.